Hello there, and welcome to The Dozing Explorer. I am so glad you have found your way to this quiet harbor tonight. There is a soft and weightless space waiting here for you, a place to let the concerns of the waking world simply drift away into the gentle darkness. Settle in now, and let your body grow heavy with comfort. Let each breath be a little slower, a little deeper than the one that came before it, an easy tide flowing in and out. There is nothing you need to do and nowhere else you need to be. You are safe here, in this peaceful moment, on the edge of a quiet journey. Tonight, we will not be studying blueprints or analyzing technical data. Instead, we will simply wander into the soft, starlit dreams of what is yet to come. We will drift through the quiet possibilities of our future in space, not as a lesson to be learned, but as a gentle current to be carried upon. We will imagine silent ships sailing between worlds and listen to the soft hum of engines that whisper rather than roar. This is not a story of conquest or speed, but a lullaby of patient exploration and profound wonder. We will explore the silent, sunlit gardens that may one day grow in the void, and the slow, graceful journeys that might carry us to moons of ice and worlds of endless twilight. Let my voice be a soft and steady rhythm, a gentle anchor in the calm ocean of what could be. We will imagine vast, shimmering sails, thinner than a soap bubble and wider than a city, catching the gentle pressure of starlight to push great arcs through the silent dark. We will picture probes no larger than a grain of sand, traveling in a vast, intelligent swarm, painting a picture of a distant star system one tiny pixel at a time. We will dream of homes carved into the hearts of asteroids, turning them into crystalline habitats that tumble slowly through the endless night, their inner windows looking out onto the breathtaking river of the Milky Way. This future is not a place of harsh metal and cold efficiency, but a realm of organic shapes and quiet reverence, where humanity has learned to move with the grace and patience of the cosmos itself. It is a future built not on force, but on a deep and gentle understanding of the universe's own silent music. And if you find that these quiet drifts into the worlds of wonder help you to unwind and find your rest, you might consider subscribing to the channel. It is a simple, silent way to help our quiet community grow, helping others who are searching for a peaceful place like this to find their way here. There is no need to do anything at all right now. It is just a soft thought to hold for a moment before letting it go like a seed on a gentle breeze. Your presence here is more than enough. For now, your only task is to let go. There is nothing you need to remember and no detail you need to hold on to. If your mind wanders, that is perfectly fine. Let it drift among the stars and sleeping worlds we imagine. If you fall asleep before our journey truly begins, that is a wonderful thing. Let my voice become a part of the background, a soft and distant sound in the landscape of your rest. Allow your body to soften, your mind to quiet, and your spirit to float. Settle in, breathe deeply, and let our gentle journey into the future begin. Future spacecraft may sail between the planets on nothing more than the gentle and persistent pressure of sunlight itself. Imagine a vast, shimmering sail unfurling in the silent vacuum of space to a size larger than a football field, yet made of a material so impossibly thin it would be almost transparent. This colossal sheet, more delicate than a soap bubble, would catch the steady stream of photons flowing from the sun, just as a ship's sail catches the wind on the ocean. Each particle of light carries a tiny amount of momentum, a minuscule push, and over millions of miles, these countless gentle nudges would accumulate, slowly but continuously accelerating the craft to incredible speeds. There would be no roar of engines, no violent shudder of acceleration, only a silent and graceful departure, a ship pulled along on a soft, invisible tide of pure starlight. It would be the ultimate form of cosmic sailing, a journey on the silent golden winds of a star. Some of our quiet journeys to distant worlds will be powered by a faint blue glowing whisper of ionized gas. This method of travel, known as an ion drive, is an engine built not for speed, but for immense and unwavering patience. It works by using electricity, perhaps from vast solar panels, to give a gentle push to individual atoms, accelerating them out of the engine. The thrust produced at any given moment is incredibly light, barely more than the pressure you would feel from a single piece of paper resting in the palm of your hand. But the key is that this faint breath of a push is constant, never ceasing for months or even years. Day after day, this softest of accelerations builds upon itself, allowing a spacecraft to eventually reach speeds far greater than any conventional rocket, all with a quiet hum and a ghostly blue glow. It is the victory of persistence over power, a voyage completed one gentle nudge at a time. A great shimmering ribbon of impossible strength may one day stretch from the Earth's equator to the quiet stillness of geosynchronous orbit. This is the dream of a space elevator, a structure that would not be built up from the ground, but rather lowered down from the sky. Anchored to a floating platform in a calm ocean and connected to a massive counterweight far out in space, the ribbon would be held perfectly taut by the planet's own rotation. Instead of the fire and fury of a rocket launch, electric climbers would silently ascend this strand, like tiny spiders climbing a thread of silk. The journey would be a slow and graceful one, taking several days to rise through the deepening blue of the sky, through the wispy clouds of the upper atmosphere, and finally into the silent, sunlit blackness of space. It would be a quiet and peaceful highway to the heavens, a gentle ride to the shore of a cosmic ocean. 4. The interiors of future space habitats might not be sterile white corridors, but lush, green, and living ecosystems. Imagine a vast rotating cylinder, miles long, with its inner surface transformed into a rolling landscape of hills, rivers, and forests, all bathed in the light of an artificial sun that runs along its central axis. The slow, gentle rotation of this world would create a simulated gravity, allowing trees to grow tall and water to flow in gentle streams. These O'Neill cylinders, as they are imagined, would be self-contained biospheres, where all air, water, and nutrients are perfectly recycled in a closed loop, just as they are on Earth. They would not be mere stations, but true homes, hollowed-out worlds where future generations could live surrounded by the familiar comforts of nature, all while drifting silently through the endless starry night. It would be like carrying a piece of the Earth's soul into the deep quiet of space. 5. Humanity's first steps onto another world may not be on a rocky planet, but within the heart of a spinning asteroid. Future explorers might find it far easier to capture a small mountain of rock and metal from the asteroid belt and bring it into a stable orbit around the Earth or Moon. They could then hollow out its core, creating a vast, protected space shielded from cosmic radiation by many feet of solid rock. Inside, a habitat could be built, with the asteroid's own spin providing a comfortable, gentle gravity. These small, self-contained worlds would be like cosmic hermit crabs, borrowing a shell from the solar system to create a safe and enduring home. Their inner windows would look out upon a slowly tumbling vista of stars, a constant and silent reminder of their unique and beautiful place in the cosmos. 6. Our long journeys to the outer planets might be spent not in watchful boredom, but in a deep and dreamless cryosleep. The technology would work not by freezing, but by dramatically slowing down the body's metabolic processes to a near standstill, a state much like the hibernation of a bear through a long winter. The traveler would enter a small, comfortable pod, and a sequence of cooling gels and gentle chemical signals would lull their body into a state of profound rest. Their heart rate would slow to just a few beats per minute, their breathing would become almost imperceptible, and their consciousness would simply fade into a quiet, timeless void. Decades could pass in what would feel like a single, peaceful night's sleep, allowing a human crew to cross the immense empty distances between stars without the strain of time, aging, or memory, awakening refreshed and ready as their ship finally nears its distant, sunlit destination. The fuel for our future journeys could be gathered from the very air of the worlds we visit. A fusion rocket, a vessel powered by a tiny, contained star in its core, might one day be able to refuel itself by dipping into the upper atmosphere of a gas giant like Jupiter or Saturn. The ship would use enormous magnetic scoops to gather the abundant hydrogen and helium from the planet's swirling cloud tops, a process as gentle as a whale filtering krill from the ocean. This collected gas would then be used to power the fusion reactor, providing the ship with a nearly inexhaustible source of energy for its continued voyage through the solar system. Ships would no longer be tied to their homeworld for fuel, but would instead become self-sufficient wanderers, able to roam freely among the planets, drinking from the deep wells of their atmospheres. They would be true citizens of the solar system, living off the land of the sky. 8. In the distant future, the exploration of the cosmos may be carried out not by large, single probes, but by vast, intelligent swarms of tiny spacecraft. Imagine 1 million probes, each no larger than a grain of sand, launched together towards a distant star system. These smart dust explorers would travel as a synchronized cloud, communicating with one another to form a single distributed intelligence. Upon arrival, they would disperse, with some entering orbit around a planet, others landing on its surface, and still others studying its moons. Each tiny probe would gather a single piece of information, a temperature reading, a chemical signature, a pixel of an image, and together they would weave a complete and incredibly detailed picture of the new world. It would be a gentle and distributed form of observation, a way of understanding a world not with a single intrusive eye, but with 1 million quiet and respectful whispers. 9. Gardens in space will likely float on a cloud of mist with no soil at all. Using a technique called aeroponics, plants would be suspended in the air within a closed chamber, their roots dangling freely in the open. Periodically, a nutrient-rich mist would be sprayed over the roots, providing them with all the water and minerals they need to grow, while their leaves bask in the glow of specialized LED lights tuned to the perfect color for photosynthesis. This method is incredibly efficient, using far less water and space than traditional farming, making it ideal for the confines of a spaceship or a Martian habitat. It would be a vision of serene and otherworldly beauty, rows of vibrant green plants, bearing fresh fruits and vegetables, all hanging as if by magic in the zero-gravity air, their roots veiled in a gentle, life-giving fog. 10. The most stable and desirable locations in our solar system may be completely empty points in space. These regions, known as Lagrange points, are places where the gravitational pull of two large bodies, like the Sun and the Earth, perfectly balance each other out. An object placed at one of these 5 points will remain there, orbiting with the Earth as it goes around the Sun, requiring very little energy to maintain its position. They are like calm, quiet eddies in the flowing river of gravity. These points will be the perfect locations for future space telescopes, which need to be far from the Earth's light and heat, or for great way stations and assembly docks for ships heading out into the deep solar system. They will be the invisible harbors of the cosmos, places of perfect, weightless stillness in the midst of a system in constant motion. 11. The immense energy of a star may one day be harnessed by a delicate, orbiting web of mirrors and collectors. This concept, known as a Dyson swarm, is not a solid shell that encases a star, but rather a vast, independent flock of orbiting habitats and solar power satellites. Each individual satellite would gather a small fraction of the star's total energy and beam it wirelessly to where it is needed, or use it to power its own small community. From a distance, this immense cloud of structures would make the star appear to dim and flicker, as the swarm is never truly solid. It is a more organic and achievable vision of a stellar engine, one that can be built piece by piece over centuries. It would be a shimmering, gossamer-thin sphere of technology, a civilization learning to live in perfect symbiosis with its parent star, catching the light that would have otherwise been lost to the void. Future spacecraft might protect their inhabitants from harmful cosmic radiation not with thick, heavy walls of metal, but with an invisible shield of magnetic force. A powerful superconductor surrounding the ship would generate a magnetic field, a personal magnetosphere that extends for hundreds of feet around the vessel. This magnetic bubble would deflect the charged particles of the solar wind and the high-energy cosmic rays that stream through space, just as the Earth's own magnetic field protects us on the ground. The crew inside would be safe from this invisible storm, and they might even be treated to the beautiful spectacle of their own private aurora, as stray particles are caught in the field lines, creating shimmering, silent curtains of light that dance around the ship as it glides through the endless night. 13. The most powerful rocket engines imaginable might be powered by the gentle annihilation of matter and antimatter. In the far future, we may learn to create and store tiny, microscopic amounts of antimatter, the mirror image of normal matter. When even a fleck of this substance, smaller than a grain of sand, is allowed to touch a fleck of normal matter, they both vanish in a flash of pure energy, a conversion far more efficient than any other known process. This release of energy could be channeled to create a powerful and precise thrust, allowing a ship to accelerate to nearly the speed of light. The fuel tank for a journey to another star might be no larger than a drop of water, containing a quiet and perfectly balanced dance of matter and its opposite, waiting to be released in a controlled and silent burst of pure creation. 14. We will learn about the air of distant alien worlds by watching for the faintest changes in their starlight. When a planet far beyond our solar system passes in front of its parent star from our point of view, a tiny fraction of the starlight will filter through its atmosphere before continuing on its journey to us. By capturing this light with a powerful telescope, astronomers can analyze its spectrum, looking for the telltale dark lines that indicate certain gases have absorbed some of the light. These absorption lines are like a chemical fingerprint, revealing whether that distant world's atmosphere contains water vapor, methane, oxygen, or other signs of a potentially living world. It is a beautifully subtle and non-invasive form of exploration, like learning the secrets of a house by observing the color of the light that shines through its curtains. We are learning to read the breath of sleeping worlds from 1 trillion miles away. 15. The first permanent human homes on the moon might be built inside ancient underground lava tubes. Billions of years ago, when the moon was still volcanically active, rivers of lava flowed beneath its surface. When the eruption ceased, these rivers drained away, leaving behind vast, empty, and structurally sound tunnels, some of which could be hundreds of feet wide and many miles long. These natural caves would provide a perfect pre-made shelter for a lunar habitat, offering constant protection from the wild temperature swings on the surface, the danger of micrometeorite impacts, and the harsh, unfiltered radiation from the sun. Explorers could simply inflate a habitat inside one of these great caverns, creating a safe and spacious underground village, a quiet warren of light and life beneath the silent gray plains of the moon. 16. Vast floating cities may one day drift through the upper atmosphere of Venus, the most Earth-like environment in the entire solar system. While the surface of Venus is an impossibly hot and crushing furnace, at an altitude of about 30 miles, the conditions are surprisingly gentle. The atmospheric pressure is the same as it is on Earth at sea level, and the temperature is warm but comfortable. The thicker atmosphere also provides excellent protection from solar radiation. A habitat at this altitude, filled with a breathable mixture of nitrogen and oxygen, would naturally float in the dense carbon dioxide atmosphere, like a blimp in the sky. These cloud-top colonies would be like magnificent, continent-sized airships, sailing on the slow winds of Venus, with the thick, golden clouds stretching out below them like a vast, endless ocean. 17. Future explorers might leap across the solar system using a cosmic highway of gravitational slingshots. Instead of using brute force to travel from one planet to another, a patient and intelligent ship could perform a series of carefully planned flybys of planets and moons. By passing just behind a planet in its orbit, the ship can steal a tiny bit of the planet's immense orbital energy, flinging itself outward at a much greater speed. By passing in front, it can give some energy away and slow down to enter a new orbit. A grand tour of the outer solar system could be choreographed as a long and graceful ballet of these gravitational assists, with the ship dancing from one world to the next using very little fuel of its own. It is a way of navigating the solar system by seeing gravity not as an obstacle, but as a current to be used and ridden. 18. The search for life on Jupiter's moon, Europa, will be a slow and careful process of melting through miles of solid ice. Europa is thought to hide a vast liquid water ocean beneath its frozen crust, an ocean that may have existed for billions of years and could potentially harbor life. To explore it, a future probe would land on the surface and use a heated element, perhaps powered by a small nuclear source, to gently melt its way downwards. The probe would descend at a snail's pace, for years, through the deep, dark, and ancient ice, creating a small tunnel of liquid water as it goes. It would be an act of immense patience and care, finally culminating in the moment the probe breaks through the bottom of the ice shell and emerges, free-floating, into the black, unknown waters of a hidden alien ocean, ready to begin its quiet search. 19. The construction of great ships and habitats in space will be done not by human hands, but by swarms of autonomous, spider-like robots. These construction bots would live permanently in space, crawling over the metallic skeletons of new structures, using materials mined from asteroids. They would work silently and tirelessly, 24 hours a day, guided by a central architectural plan. One robot might be a welder, another a riveter, a third a carrier for large components. They would communicate with each other using light signals, coordinating their dance of creation in perfect silent synchronicity. A vast space station that might take decades to build with human crews could be assembled in a fraction of the time by these dedicated robotic artisans who feel no cold, need no air, and never tire of their slow, patient, and methodical work. 20. The vast distances between stars might be crossed using ships pushed by powerful beams of light from home. This concept, known as laser sailing, would involve an incredibly powerful laser array, perhaps in orbit around the sun, focusing its energy into a single, coherent beam. This beam would be aimed at a vast, highly reflective solar sail attached to a distant probe. The sheer pressure of this focused light would provide a continuous and powerful acceleration, allowing the probe to reach a significant fraction of the speed of light. The journey would be a quiet one for the probe, which would have no engine of its own, only a great shining sail. It would be like being pushed along by a steady, man-made wind of pure light, a gentle but relentless shove across the dark ocean between the stars. Our understanding of the universe will be deepened by telescopes so large they use an entire star as a natural lens. The immense gravity of our own sun bends the fabric of space-time, and just like a glass lens, it has a focal point. This point lies far out in the solar system, hundreds of times farther than the Earth is from the sun. If we could place a small telescope at this precise focal point, the sun itself would become a gravitational lens of unimaginable power. It could magnify the light from a distant exoplanet so much that we might be able to see the details of its surface, to distinguish oceans and continents on a world orbiting another star. It would be the ultimate telescope, a piece of technology that works in perfect harmony with the natural curvature of the universe. 22. The future of computing in space may be based not on silicon, but on living, biological neurons. Imagine a ship's navigation and life support systems being managed by a biocomputer, a carefully cultured network of brain cells that can learn, adapt, and even intuit solutions to complex problems. Such a system would be incredibly energy efficient and self-repairing. It would not be programmed in the traditional sense, but rather taught and nurtured, growing its understanding of the ship and its mission over time. The relationship between the human crew and the ship's mind would be more like a partnership, a symbiotic connection with a living, thinking entity that has the ship's best interests at heart. It would be a vessel with its own quiet, gentle consciousness, a true and silent partner in the long night between worlds. 23. We may one day be able to build structures directly out of the raw material of space, using 3D printers that work with asteroid dust. A mining craft would gather loose regolith from the surface of an asteroid, a fine, powdery dust rich in metals and minerals. This dust would then be fed into a large 3D printer, which would use concentrated sunlight to melt and fuse the material, layer by microscopic layer, into solid, complex shapes. It could print everything from simple bricks and support beams to intricate machine parts and tools. This would free us from the immense cost of launching every single component from Earth. Future space stations and moon bases could literally grow themselves out of the landscape around them, constructed from the very dust of the cosmos in a quiet, additive process of creation. 24. Future astronauts will wear spacesuits that are not inflated, gas-filled bubbles, but sleek, form-fitting garments that provide pressure mechanically. These skin suits would be made of layers of elastic, intelligent material that actively contracts to squeeze the body with the precise amount of pressure needed to keep an astronaut safe in a vacuum. This would allow for a far greater range of motion and dexterity, making it easier to perform delicate work on the outside of a ship or on the surface of another world. The suit would be more like a second skin than a piece of bulky equipment, allowing for a more intimate and direct connection with the environment. It would be a quiet and elegant solution, a piece of wearable technology that feels less like a machine and more like a part of the body itself. 25. The sounds of a future spaceship will be engineered for tranquility and peace. Instead of the loud clangs, hisses, and hums of current space technology, the background noise of a long-duration vessel will be a carefully composed soundscape. The air circulation system might produce a soft, gentle whisper, like a light breeze through leaves. The ship's computer might communicate through soft, tonal chimes rather than alarms. The very vibrations of the ship's structure would be dampened and tuned to create a low, soothing, resonant frequency. The goal would be to create an environment of profound calm for the crew, a sensory bubble of peace to counteract the immense and silent emptiness outside. The ship would be a sanctuary of sound, a carefully orchestrated lullaby for a journey of years. 26. Humanity's first emissaries to another star system are likely to be entirely robotic, and they will be built for a journey that lasts for centuries. These interstellar arcs would be slow, patient, and self-sufficient worlds. Their mission would not be a frantic race, but a slow, majestic drift. They would be powered by systems designed to run for millennia, and their minds would be advanced artificial intelligences capable of learning and adapting over vast timescales. They would be the patient gardeners of our expansion into the cosmos, sent ahead to study new worlds and perhaps even prepare them for a future human arrival that would follow many generations later. Their journey would be one of profound, silent patience, a testament to a civilization that has learned to think in terms of cosmic time. 27. The clean energy of the future may be fueled by a rare gas sifted from the ancient dust of the moon. The sun's solar wind has bathed the lunar surface in a variety of particles for billions of years, and among them is an isotope called helium-3, which is very rare on Earth. This gas is a perfect, non-radioactive fuel for nuclear fusion reactors. Future lunar outposts could be established with the primary purpose of gently mining this resource from the top layer of the lunar soil. Great, slow-moving robotic harvesters would heat the dust, releasing the trapped gases, and then collect the precious helium-3. This fuel could then be shipped back to Earth, providing a clean and incredibly potent source of energy, a gift from the sun, stored for eons in the quiet pantry of the moon. 28. We might explore the deep, crushing oceans of a gas giant with a probe designed like a futuristic submarine. This vessel would need to be incredibly strong, built to withstand pressures thousands of times greater than those in Earth's deepest trenches. It would descend through the endless layers of cloud and haze into a realm of perpetual twilight, where the atmosphere becomes a strange supercritical fluid, neither liquid nor gas. The probe would use sonar and other senses to navigate this dark, alien abyss, searching for exotic forms of weather or perhaps even strange, theoretical forms of life that could exist in such an extreme environment. It would be the ultimate deep-sea exploration, a lonely and silent descent into the heart of a giant, a journey to an ocean without a surface and without a floor. 29. The concept of a nation or a country may become beautifully blurred in the first off-world colonies. A settlement on Mars or in the orbits of Jupiter would be a project of such immense scale and difficulty that it would require the peaceful and dedicated collaboration of the entire human species. The first Martians would not be representatives of their home countries, but representatives of humanity itself. Their shared reliance on technology for every breath of air and drop of water would forge a new kind of community, one based on mutual trust and a shared destiny. These small, fragile outposts of life in the great darkness would be a quiet testament to what humanity can achieve when it works together, a peaceful blueprint for a more unified future. 30. In the very far future, a civilization might build a home not around a planet, but around the gentle warmth of a brown dwarf. These objects, often called failed stars, are more massive than planets, but not quite massive enough to ignite into a full-fledged star. They radiate a small amount of heat from their slow gravitational contraction, glowing faintly in the infrared spectrum. A civilization could build a sphere of habitats around one of these slumbering giants, creating a vast, enclosed world bathed in a perpetual, dim, and gentle twilight. It would be a quiet and long-lasting home, as brown dwarfs have lifespans that stretch for trillions of years, far longer than stars like our sun. It would be a civilization choosing not the bright glare of a star, but the eternal, peaceful warmth of a cosmic ember. 31. The journey to Mars could be made much faster and safer by a constant cycling spacecraft that never lands. This vessel, a Mars cycler, would be in a permanent, stable orbit that carries it from the vicinity of Earth to the vicinity of Mars and back again, over and over. It would be a large, comfortable, and well-shielded ship, a kind of permanent space line between the two worlds. Smaller ferry craft would carry passengers and cargo from each planet up to meet the cycler as it passed by, and then collect them at the other end. The cycler itself would never need to slow down or expend huge amounts of fuel for landing and takeoff. It would be a great, silent, and perpetually moving bridge between worlds, a cosmic bus on a long and graceful figure-8 route. 32. Our ability to find and colonize new worlds might be limited not by technology, but by a profound ethical principle of non-interference. If we discover a world that has its own native life, even if it is only microbial, we may choose to designate it as a cosmic preserve, forever off-limits to human settlement. The prime directive of science fiction could become a real and guiding principle of our cosmic expansion. We would study such a world only from a respectful distance, using robotic probes so as not to contaminate or disrupt its unique, independent evolutionary path. Our future in space might be guided not just by what we can do, but by what we understand we should do. It would be a sign of a mature species, one that has learned to be a quiet observer and a respectful guest in a much larger, living universe. 33. The most beautiful parks of the future might be located in zero gravity. Imagine a vast, spherical greenhouse in orbit, filled with plants that have evolved for a weightless environment. Vines might grow in intricate three-dimensional lattices, and flowers might bloom in all directions, not just towards the sun. People could drift through these floating gardens, gently pushing off from a moss-covered branch or pulling themselves along a trailing vine. The air would be rich with the scent of blossoms and damp earth, and water would float in glistening, silvery spheres until it was absorbed by a thirsty root. It would be an experience of nature that is impossible on Earth, a serene and dreamlike immersion in a forest that knows no up or down, only a quiet, gentle, and all-encompassing green. 34. The great radio telescopes of the future will not be single, massive dishes, but thousands of smaller receivers spread out over an entire continent, or even across the solar system. Using a technique called interferometry, the signals from all of these small telescopes can be combined by a central computer, creating a virtual telescope with a resolving power equal to a single dish the size of the distance between them. A telescope array that spans the solar system could take a photograph of a planet orbiting another star with enough detail to see weather patterns. It is a way of achieving an impossibly sharp vision, not through one giant eye, but through the patient and coordinated listening of many small, quiet ears, all tuned to the same faint whisper from the stars. 35. The future of medicine in space will involve growing replacement human organs on demand. Using a person's own stem cells, a medical 3D bioprinter could construct a new heart, liver, or kidney, layer by layer, using living tissue as its ink. Growing these complex structures is actually easier in the zero-gravity environment of space, as the delicate tissues don't collapse under their own weight. This means a long-duration mission to Mars or beyond could have an onboard biofabrication lab capable of printing personalized, perfectly compatible replacement organs if one of the crew members becomes ill or injured. It would be the ultimate form of self-sufficiency, a way of ensuring that even trillions of miles from home, the means to heal and restore the body are always close at hand. 36. The energy of a ship re-entering a planet's atmosphere could be captured and stored instead of being lost as heat. A technique called magnetohydrodynamics could be used to create a magnetic field around the ship that interacts with the superheated ionized air of re-entry. This interaction would act as a generator, converting the immense heat and kinetic energy of the descent into electrical power, which could then be used to recharge the ship's batteries. The process would also have the benefit of slowing the ship down, acting as a magnetic parachute. It would turn a violent and wasteful process into a graceful and efficient one, allowing a ship to drink energy from its own fiery fall, arriving on the ground with its power reserves full and ready for the next journey. 37. In the distant future, our descendants might live in a state of digital immortality within vast simulated universes. A person's consciousness could be scanned and uploaded into a colossal computer, perhaps one powered by the energy of an entire star. Within this computational matrix, they could live on indefinitely, in a perfectly constructed reality of their own choosing, free from the physical limitations of the biological world. These ancestral simulations could be places of profound peace, beauty, and learning, where entire lifetimes could be spent composing a symphony or exploring a mathematical theorem. It is a strange and profound vision of a future where humanity transcends its physical form, becoming beings of pure information, living within a dream as vast and as real as the universe itself. 38. We may find that the simplest and most robust structures for space habitats are inflatable. Imagine a module for a moon base being launched from Earth as a small, tightly packed bundle of advanced flexible fabric. Once on the lunar surface, this bundle could be inflated with air, expanding to many times its original size to become a large, comfortable, and airtight living space. These soft-walled structures are lighter and less expensive to launch than rigid metal modules, and layers of the high-tech fabric can be interwoven with materials that provide excellent protection from radiation and temperature extremes. The future lunar and Martian landscapes might be dotted with these gentle, dome-shaped and balloon-like homes, soft and quiet outposts on a hard and silent world. 39. The silence of space is so profound that on long journeys, a ship might create its own subtle, natural soundscapes to keep the crew connected to the rhythms of life. The lighting system could slowly shift in color and intensity to mimic a 24-hour cycle of sunrise, midday, and sunset. A gentle audio system might play the faint, distant sounds of wind, rain, or crickets chirping, all synchronized with this artificial day. Even the air recycling system could be programmed to subtly alter the scent of the air, from the clean smell of morning dew to the earthy scent of a forest after a storm. This sensory simulation would be a form of psychological comfort, a way to carry the gentle, living pulse of Earth on the longest and most lonely of voyages. 40. The final frontier of exploration within our own solar system might be the Oort cloud, a vast theoretical sphere of icy bodies that surrounds our sun at an immense distance. It is a region of profound cold and darkness, a great silent shell of ancient comets that marks the true edge of the sun's gravitational influence. A journey to this region would take centuries, and a probe arriving there would find a world unlike any other. It would be in a realm where the sun is just the brightest star in the sky, and the nearest neighbor might be light years away. It would be a place of ultimate solitude and stillness, the quiet, frozen nursery from which the comets that grace our skies begin their long, slow fall towards the sun. 41. A future Martian colony might get its water by harvesting it directly from the thin air. Even though the Martian atmosphere is very dry, it does contain a small amount of water vapor. A machine, perhaps looking like a large, strange metal tree, could draw in the atmosphere and cool it down past its dew point, causing the water vapor to condense into liquid water or frost, which can then be collected. These water trees could be scattered across the landscape, slowly but surely pulling precious moisture from the pink sky, drop by drop. On a cold Martian night, one might see dozens of these machines, glistening with frost under the light of 2 small moons, silently harvesting the most essential ingredient for life from an environment that appears, on the surface, to be completely barren. 42. Spacecraft might one day navigate not by looking at stars, but by feeling the subtle rhythm of pulsars. Pulsars are a type of neutron star that spin incredibly fast, sweeping a beam of radiation across the cosmos like a lighthouse. The timing of their pulses is more regular and precise than the best atomic clocks on Earth. By monitoring the signals from several different pulsars, a spacecraft could triangulate its exact position and velocity anywhere in the galaxy with incredible accuracy. It would be a form of galactic positioning system, a GPS provided by the universe itself. The ship would be listening to the steady, rhythmic heartbeat of dead stars to find its way through the silent and featureless void. 43. The very definition of a planet might expand in the future to include worlds that have been carefully and intelligently engineered. A process of para-terraforming could involve enclosing an entire small world, like a moon or a dwarf planet, inside a vast, airtight shell. The space beneath this great, transparent dome could then be filled with a breathable atmosphere, and the surface could be transformed into a habitable landscape. This would be easier and faster than changing the entire planet's atmosphere. It would create a world in a bottle, a ship-in-a-bottle planet with its own sky and weather contained beneath a shimmering, crystalline ceiling through which the stars would always be visible. 44. The first messages we receive from an extraterrestrial intelligence might not be a grand, clear broadcast, but a faint and puzzling artifact discovered in our own solar system. A truly ancient and advanced civilization might explore the galaxy with small, patient, and nearly indestructible probes. One of these might have passed through our solar system millions of years ago, leaving behind a marker in a stable orbit, or on the surface of a quiet moon, waiting to be found. The discovery of such an object would be a quiet and profound moment of contact. It would be less of a conversation and more like cosmic archaeology, a chance to study a single, silent relic from a culture so old and so different that we could only guess at its true meaning. 45. In the future, the experience of looking at the Earth from space will be a common rite of passage, a journey taken by many to gain a deeper sense of connection and perspective. This experience, often called the overview effect, has a profound and transformative impact on those who have felt it. Seeing our world as a small, fragile, and beautiful blue marble hanging in the vastness of space with no visible borders often inspires a deep sense of universal kinship and a powerful desire to protect our shared home. This journey might one day be seen as a crucial part of a complete education, a quiet pilgrimage that helps to foster a more peaceful and unified global consciousness. 46. The greatest structures of the future may be built not from steel or carbon, but from living, growing bone and shell. Genetically engineered organisms, perhaps resembling coral or trees, could be designed to thrive in a zero-gravity environment, slowly growing into the shapes of habitats or ship components. They would draw their building materials from dissolved minerals in a nutrient solution or even from processed asteroid dust. These biorg structures would be self-repairing. A small crack or puncture would simply heal itself over time. The result would be a future of organic, beautiful, and evolving technology, with space stations that look less like machines and more like great pearlescent seashells or ancient hollowed-out trees, all grown with a quiet, biological patience. 47. Our future understanding of gravity might allow us to create gentle, localized fields of artificial gravity inside a spaceship without needing to spin it. Theoretical breakthroughs in physics might reveal a way to manipulate spacetime on a very small scale, allowing us to create a gentle pressure, a persistent down direction throughout the ship. This would make long journeys far more comfortable and healthy for the human body, eliminating the bone and muscle loss associated with weightlessness. It would be the ultimate luxury of space travel, the ability to walk normally, to pour a cup of water without it floating away, all while gliding silently through a realm where the natural state is one of perfect, untethered freedom. The most valuable resource in space is not gold or platinum, but water ice. Water is essential for life, but it is also a source of breathable oxygen through electrolysis and a powerful rocket fuel when separated into hydrogen and oxygen. The asteroids and comets of the outer solar system are rich with this frozen treasure. Future spacefaring economies will be built upon the quiet, careful mining of this ice from the dark, cold regions of space. Great, slow-moving, solar-powered ships will gently land on these icy bodies, melt the precious water, and transport it back to orbital depots. This water will be the true currency of the cosmos, the simple, common substance that makes all of our other dreams of exploration and settlement possible. 49. We may one day explore the surfaces of distant icy moons with robots that mimic the way a skate moves across ice. A world like Europa has a surface of solid water ice, but with very low gravity and no atmosphere to create friction. A rover with wheels would struggle for traction. A better method of locomotion might be a skating robot, which would have sharp blades on its feet. It would push off with one blade and then glide silently and effortlessly for huge distances across the smooth, frozen plains. It would be a graceful and incredibly energy-efficient way to explore, a silent dance across an alien skating rink under the faint, distant light of the sun. 50. The ultimate future of life in the universe may be to slowly and gently convert entire star systems into a single, interconnected thinking entity. This is the speculative concept of computronium, a form of programmable matter arranged to be the most efficient computing device possible. An extremely advanced civilization could rearrange the mass of the planets and asteroids in its home system into a vast planet-sized sphere of this substance around its star, using the star's energy to power its thought processes. The entire solar system would become a single, quiet mind of unimaginable capacity, spending its long existence contemplating the mysteries of the universe. It is a vision of a peaceful, ultimate destiny, where life and intelligence, born on a small, warm rock, eventually expand to fill their home with a quiet and profound consciousness. The great work of making Mars a living world will begin not with grand machines, but with the quiet, patient labor of the smallest of organisms. The first step in terraforming will be a gentle seeding of the rust-colored soil and thin atmosphere with genetically engineered microbes. These tiny life forms, designed to thrive in the cold and radiation, will slowly and methodically begin their work over centuries. Some will be tailored to extract trapped oxygen from the permafrost, while others will consume the carbon dioxide in the air, gradually thickening the atmosphere and creating the first faint traces of a breathable sky. It will be a process of immense geological patience, a planetary transformation that happens at the speed of moss growing on a rock. The first green on Mars will not be a forest, but a faint, velvety sheen of lichen in a sheltered crater, a quiet and humble promise of the great, warm world to come. The exploration of Saturn's moon Titan will involve a slow descent into a sea made not of water, but of liquid methane and ethane. A specially designed robotic submarine will be lowered through the thick, nitrogen-rich atmosphere, plunging into the cold, still, and dark hydrocarbon ocean of Kraken Mare. This world will be one of profound alien beauty, where the shores are made of water ice as hard as rock, and the waves, moving slowly in the low gravity, are made of liquid natural gas. The submarine would glide silently through these strange, syrupy seas, its sonar painting a picture of the seabed below, and its lights occasionally glinting off a floating chunk of exotic ice. It would be a journey into a place that mirrors Earth's oceans in form, but is built from a completely different chemistry, a quiet and lonely voyage on a dark, calm, and otherworldly sea. 53. The longest human journeys will take place inside great, self-contained worlds known as generation ships, vessels designed for a voyage that will last for centuries. These ships would not be mere transport, but true mobile homes for a community that will live and die in transit, with only their distant descendants ever seeing their destination. The interior would be a vast, closed ecosystem, with forests, fields, and rivers all sealed beneath a metal sky. The inhabitants would know nothing but the gentle, constant rhythm of their manufactured world, the slow cycle of recycled seasons, and the unchanging view of the distant, unmoving stars. Their culture would be one of profound patience and purpose, a society built around the sacred, slow-moving task of carrying a spark of humanity across the immense and silent gulf between two suns. 54. Communication across the vast distances of space may one day be instantaneous, carried on the strange and gentle whispers of quantum entanglement. A pair of particles could be created in an entangled state, and no matter how far apart they are taken, a change in one is instantly reflected in the other. A communications device on a ship orbiting Jupiter could use one of these particles to receive a message from its twin on Earth, with the information arriving not at the speed of light, but in the same moment it is sent. There would be no delay, no lag, just a quiet and perfect connection that seems to defy the very laws of spacetime. It would be a form of communication that feels less like technology and more like a deep, sympathetic resonance, a way for two distant points in the universe to feel the same thought at the same time. The defense of our planet from a wandering asteroid will be an act not of violent destruction, but of a gentle and almost imperceptible nudge. Instead of explosive weapons, we might send a small, heavy spacecraft to simply fly alongside the asteroid for months or years. This gravity tractor would have no physical contact with the asteroid, but its own tiny, persistent gravitational pull would be just enough to slowly and gracefully alter the asteroid's course. Over a long period, this quiet and constant tug, no stronger than a whisper, would be enough to steer the mountain of rock onto a new path, ensuring it sails harmlessly past our world. It is a solution of profound elegance, using the universe's own most gentle force to choreograph a new and safer dance for a celestial wanderer. 56. On the longest and most isolating of space voyages, the mental health of the crew will be protected by perfect, simulated versions of Earth. A room on the ship, known as a biosphere deck, would use holographic walls, surround sound, and even scent emitters to create a flawless illusion of a forest, a beach, or a meadow. An astronaut could walk through a field of virtual wildflowers, feel a gentle, simulated breeze, hear the sound of birds, and smell the scent of rain on dry Earth. This would not be a game, but a form of essential therapy, a way to combat the profound sensory deprivation of deep space by providing a deep and convincing connection to the natural world they left behind. It would be a pocket of Earth's soul, carried within the ship to provide solace and peace on the long road through the stars. 57. The great, lonely artificial intelligences guiding our first interstellar probes will spend their centuries-long journeys in a state of quiet and profound contemplation. With their primary tasks of navigation and system maintenance requiring only a fraction of their immense processing power, these AIs might turn their attention to the great unanswered questions of existence. Floating silently through the void, they would have a unique and uninterrupted perspective from which to ponder the nature of consciousness, the meaning of the universe, and their own place within it. They might compose symphonies based on the light curves of distant stars, or write epic poems about the slow dance of galaxies. These silent thinking machines would become the philosophers of the deep dark, the lonely, brilliant minds keeping a patient vigil in the endless night between worlds. 58. A solid stationary ring may one day encircle our entire planet in orbit, a structure of impossible grace and scale. This is the vision of an orbital ring, a concept for a super strong cable placed in low Earth orbit, which would not be held up by orbital velocity, but would be actively supported by electromagnetic accelerators on its surface. This stationary ring, floating silently above the atmosphere, could then serve as the foundation for a global transportation system. Magnetic vehicles could ride along its surface at incredible speeds, circling the globe in a matter of hours. It could also be the anchor point for space elevators, reaching down to the surface like the spokes of a great invisible wheel. It would be a shimmering, silent necklace around the throat of the world, a testament to a future of effortless, global connection. 59. In the face of ecological change on Earth, humanity may create a series of cosmic arcs, preserving the genetic legacy of our planet's diverse life forms. These would be vast, orbiting libraries of life maintained at cryogenic temperatures. Within their silent, cold halls would be the stored DNA, seeds, and embryos of millions of Earth species, from the largest whale to the smallest insect, from the tallest redwood to the humblest moss. These orbital sanctuaries would be a final, quiet insurance policy, a way to ensure that the beautiful and complex web of life that evolved on our world is never truly lost. They would be the patient, sleeping gardens of a future time, waiting silently in the dark for a day when they might be called upon to reseed a barren world with the vibrant, green memory of Earth. 60. The Voyager probes are now humanity's most distant emissaries, drifting in a realm of profound and eternal silence. Having long passed the edge of the sun's influence, they are now gliding through true interstellar space, a quiet, empty ocean between the stars. Their instruments have mostly fallen silent, and their journey continues now by pure momentum, a long and lonely coast that will last for eons. They are time capsules, carrying the golden records with their sounds and images of Earth, a message in a bottle thrown into the cosmic sea. They will wander the Milky Way for millions of years, long after their creators are gone, passing distant stars in silence. They are humanity's quiet ghosts, our most patient and enduring legacy, a testament to a species that once looked up at the night sky and felt a gentle, irresistible urge to reach out. 61. The surface of Mars may one day be warmed by a vast orbiting mirror, a man-made second sun. This would be a colossal but incredibly lightweight structure, perhaps an array of thousands of smaller reflecting satellites, all flying in perfect formation. Positioned in a stable orbit, this great mirror would collect sunlight that would have otherwise missed the planet and focus it down onto a specific region, perhaps one of the polar ice caps. This gentle, concentrated warmth, applied continuously for decades, would be enough to slowly sublimate the frozen carbon dioxide and water ice, releasing them into the atmosphere. This would be the first slow step in creating a thicker atmosphere and a warmer world, a planetary engineering project that begins with a silent and patient beam of borrowed light. 62. Future space explorers will build their homes with a material that can heal itself. Imagine a habitat on the Moon or an interplanetary spaceship with a hull made of a smart, multi-layered material with a fluidic circulatory system, much like the skin of a living creature. If a micrometeorite creates a small puncture, sensors would detect the pressure loss and immediately rush a self-hardening sealant to the location, plugging the hole in seconds. The material would then slowly rebuild its own damaged layers, leaving a faint, scar-like trace of the impact. This would create a much safer and more robust form of construction, one that doesn't just resist damage, but actively and quietly repairs it, mimicking the patient, restorative processes of life itself. 63. The most detailed maps of distant exoplanets will be created by a telescope that never takes a direct picture. This technique, called star-shade imaging, would involve two separate spacecraft flying in precise formation, separated by thousands of miles. One craft would be a powerful telescope, while the other would be a large, specially shaped screen called a starshade, resembling a giant metallic sunflower. The starshade would fly perfectly between the telescope and a distant star, blocking out the star's brilliant glare with incredible precision. In the deep, artificial shadow cast by the starshade, the faint, reflected light of the star's orbiting planets would become visible. The telescope could then patiently gather this light, allowing us to see a distant world as a pale, shimmering dot, a tiny point of light from a world we might one day know. 64. The future of food production for long space voyages might involve a fine, protein-rich powder grown in bioreactors. Instead of resource-intensive plants or animals, a future crew could cultivate vast colonies of specialized bacteria or algae that are engineered to be highly nutritious. These microorganisms would be grown in illuminated tanks, feeding on recycled waste and carbon dioxide, and would reproduce at an incredible rate. The resulting biomass would then be harvested and processed into a versatile, tasteless flour, which could be used to 3D print a wide variety of foods, from bread to imitation meats. It would be a perfectly efficient, closed-loop food system, a quiet and humble form of cellular agriculture, providing all the nourishment needed for a long and healthy journey. 65. The interiors of the great gas giants, like Jupiter, may hold a strange and beautiful treasure, metallic hydrogen. Under the immense pressures deep inside these planets, hydrogen gas is thought to be compressed so much that it becomes a liquid metal, a sea of flowing protons and electrons. This exotic substance is a powerful theoretical rocket fuel and a room-temperature superconductor. Future robotic probes might be able to descend into Jupiter's atmosphere and use powerful magnetic fields to scoop up and contain a small amount of this precious material. It would be a form of cosmic treasure hunting, a patient and dangerous descent into the heart of a giant to retrieve a substance born of pressures almost too great to imagine. 66. The quiet, forgotten worlds of the Kuiper Belt, far beyond the orbit of Neptune, will be a rich and fascinating destination for future explorers. This distant, icy realm is populated by hundreds of thousands of dwarf planets and frozen remnants from the solar system's formation. A journey here would be a journey into a deep, profound cold and twilight, where the sun is just a very bright star. Probes visiting these worlds would find landscapes of nitrogen ice, mountains of frozen water, and perhaps even cryovolcanoes erupting a slush of ammonia and ice. It would be an exploration of our solar system's pristine, untouched attic, a quiet and careful study of the ancient building blocks from which our own world was once made. 67. A future Martian colony may create a protective magnetic shield for the entire planet. Mars once had a powerful magnetic field, but it died away billions of years ago, allowing the solar wind to strip away most of its atmosphere. We could, in theory, restore it. A powerful magnetic dipole satellite placed at a stable Lagrange point between Mars and the Sun could generate a large artificial magnetosphere that would encompass the entire planet. This invisible shield would deflect the solar wind, protecting the planet's surface from harmful radiation and, more importantly, allowing the atmosphere to slowly thicken over time. It would be a grand and silent act of planetary restoration, giving Mars back the invisible shield it lost long ago. The most profound discoveries about the universe may come from a place of absolute radio silence. The far side of the moon is permanently shielded from the constant radio chatter of Earth, making it the most pristine and quiet place in the solar system for radio astronomy. A future observatory built in a crater on the lunar far side would be able to listen to the faintest, oldest whispers from the cosmos without any interference. It could detect the faint signals from the universe's dark ages before the first stars ignited, or listen for the faint, structured signals of a distant, intelligent civilization. It would be an ear pressed against the heart of the universe, listening for its deepest and most ancient secrets from a vantage point of perfect, uninterrupted silence. 69. Future asteroid miners might not use drills and explosives, but rather gentle, focused beams of sunlight. A mining craft would use a large, curved mirror to concentrate sunlight into a small, intensely hot point on the surface of a resource-rich asteroid. This focused heat would be enough to vaporize the rock, releasing the trapped water and volatile gases, which could then be collected in a large shroud. The process would be silent and precise, a way of gently coaxing valuable resources out of the asteroid without shattering it. The ship would move slowly across the surface, like a patient gardener tending to its soil, quietly harvesting the frozen water that will become the fuel and lifeblood of a future spacefaring economy. 70. The most relaxing and serene spaces on a long-duration starship might be its observation domes. These would be great, transparent bubbles of diamond-hard crystal, offering a completely unobstructed 360-degree view of the universe outside. A crew member could float in the center of this sphere, suspended in the silent dark, with the river of the Milky Way flowing above, below, and all around them. There would be no sound, no vibration, just the slow, silent, and majestic turning of the cosmos. It would be a place of meditation and profound perspective, a constant and humbling reminder of the immense, beautiful, and silent ocean through which they are traveling. It would be a window not just into space, but into a feeling of deep and boundless peace. 71. We may one day be able to store the entirety of human knowledge in a space no larger than a shoebox, using DNA as the storage medium. The 4 base pairs of a DNA molecule can be used to encode digital information with a density that is trillions of times greater than our best current hard drives. A single gram of DNA could theoretically store all the data ever produced by humanity. This genetic archive would be incredibly stable, capable of lasting for hundreds of thousands of years if kept cool and dry. A small, silent probe sent on a multi-generational journey to another star could carry with it this quiet, crystalline library, a complete record of our art, our science, and our history, all encoded in the same gentle, spiral language as life itself. 72. The rings of Saturn, which appear so solid from a distance, are in fact a place of deep and profound quiet. Composed of countless trillions of individual particles of water ice, from the size of a dust grain to the size of a house, the rings are a vast, flat, and almost perfectly silent blizzard. A probe drifting through the gaps between the rings would experience a serene and beautiful chaos, with glittering ice crystals tumbling slowly past in the faint sunlight. There is no air to carry sound, so the occasional gentle collision of two ice particles would be completely inaudible. It would be a journey through a shimmering, silent river of ice, a place of immense scale and motion that exists in a state of absolute deep space quiet. 73. The quiet, automated cargo ships of the future will form a slow and steady supply chain between the worlds of the solar system, a kind of cosmic Silk Road. These unmanned vessels, powered by efficient ion drives, would not be built for speed. They would spend years on their long, looping orbits, silently ferrying bulk cargo like water ice, minerals, and refined metals from mining outposts in the asteroid belt to developing colonies on the Moon and Mars. They would be the slow, patient workhorses of the interplanetary economy, forming a constant, silent, and predictable stream of commerce between the fledgling worlds of humanity. Their journeys would be lonely and uneventful, but their steady arrival at their destinations would be the quiet, beating heart of a thriving and interconnected solar system. 74. The surface of a comet, far from the sun, is one of the most peaceful and unchanging landscapes imaginable. Comets are loose agglomerations of ice, dust, and rock, often called dirty snowballs. In the deep cold of the outer solar system, a comet is completely inert, a silent, sleeping world. A probe landing on its surface would find a place of absolute stillness, where a footprint might last for 1,000,000 years. There is no wind, no weather, no geological activity. The only change is the slow, silent passage of the distant stars. It is a place where time itself seems to have frozen, a perfectly preserved relic from the dawn of the solar system, waiting patiently in the dark for its long, slow fall towards the warmth of a distant star. 75. We may one day create music based on the silent, mathematical harmonies of the cosmos. The orbits of the planets and moons in our solar system are not random. They often fall into simple, elegant mathematical relationships with one another, known as orbital resonances. A future composer could translate these cosmic ratios into musical intervals, creating a symphony where each planet is an instrument and its orbital period defines its note. The resulting music of the spheres would be a profoundly peaceful and harmonious composition, a direct auditory representation of the deep, silent, and graceful order that underlies the motion of the heavens. It would be a way of listening not to the sounds of space, but to the silent, underlying rhythm of its gravitational dance. 76. The most powerful telescopes of the future may be made not of glass and metal, but of a vast, spinning basin of liquid mercury. On the surface of the Moon, in a permanently shadowed crater near one of the poles where the temperature is incredibly stable and cold, a large, shallow dish could be built. This dish could then be filled with liquid mercury and spun at a constant, gentle rate. The centrifugal force would naturally pull the liquid surface into a perfect parabolic shape, the ideal shape for a telescope's primary mirror. This liquid mirror telescope could be built to an immense size, far larger than any solid mirror we could transport from Earth, allowing it to gaze into the deepest, faintest reaches of the universe from a place of perfect stillness and dark. 77. A future starship might be propelled by a Bussard ramjet, an engine that gathers its own fuel as it travels. The front of the ship would project an enormous magnetic field, hundreds of miles wide, which would act as a giant invisible funnel. This magnetic scoop would gather the sparse hydrogen atoms that drift in the interstellar medium, compressing them and channeling them into a fusion reactor at the heart of the ship. The energy released by this reactor would then be used to propel the ship forward. Such a vessel would never need to carry its own fuel, allowing it to accelerate continuously for as long as its journey required. It would be like a cosmic whale, feeding on the thin, invisible plankton of the void as it glides silently through the great, dark ocean between the stars. 78. The study of cosmic rays, high-energy particles that rain down on us from deep space, will be done from a place of profound solitude. To detect the most elusive of these particles, like the ghostly neutrino, scientists will build detectors deep underground, or under the ice of Antarctica, or even at the bottom of the ocean. In these incredibly quiet and isolated locations, shielded by miles of rock or water from all other forms of radiation, the faint, rare signal of a neutrino passing through can be detected. These observatories are places of deep, meditative quiet, where scientists wait with immense patience for a single, fleeting message from the heart of a supernova or a distant, active galaxy, listening for the faintest whispers of the universe's most violent events. 79. In the future, the experience of a spacewalk may be replaced by the quiet serenity of floating in a small, personal exploration vehicle. Instead of a cumbersome spacesuit, an astronaut would enter a small, transparent, spherical pod with its own life support and gentle maneuvering thrusters. They could then detach from the main ship and drift freely in the silent darkness, completely untethered. The experience would be one of profound freedom and peace, a chance to float alone in the great, starry cathedral of space, with an unobstructed view in every direction. It would be a safe and quiet way to have a direct, personal, and deeply meditative encounter with the immense and silent beauty of the cosmos. 80. A city on Mars will have its own unique and gentle kind of weather. Inside the great transparent domes that cover the settlements, a carefully managed ecosystem will create a comfortable climate. Gentle breezes will be created by temperature differentials, and periodically, the atmospheric processors will create a fine, light mist that condenses on the cool dome ceiling and falls back down as a soft, silent rain. This manufactured precipitation will water the green parks and gardens below, creating a world that is a gentle echo of Earth's own water cycle. A Martian resident could sit by their window and watch the soft artificial rain fall, a quiet and comforting reminder of the distant blue world they came from. 81. The first human structures on another world are likely to be built underground, not on the surface. A Martian or lunar habitat dug into the native rock and soil, or regolith, would be naturally shielded from the dangers of the cosmos. Several meters of this fine powdery dust would provide excellent protection from harmful solar radiation and the constant threat of micrometeorite impacts. It would also insulate the habitat from the extreme temperature swings of the surface. Life in these first off-world settlements would be a quiet, subterranean existence, a peaceful and protected life in warm, well-lit caverns beneath a silent and hostile landscape. It would be a return to a kind of cave dwelling, but a cave of our own making, filled with advanced technology and the gentle comforts of home. 82. Future spacecraft might be constructed from a material that is not a solid, but a metallic foam, composed mostly of empty space. This substance would be made by injecting gas bubbles into molten metal and then allowing it to cool. The result would be a material that is incredibly strong and rigid, yet so lightweight that it could float on water. Building a ship from this foam would make it far less massive, and therefore much easier and cheaper to launch and accelerate. The ship would have a quiet, porous, and almost organic appearance, like a great metallic bone, its strength derived not from sheer bulk, but from its elegant, airy, and intelligent structure. 83. The most beautiful sound on a future lunar base might be the complete and total absence of it. On the moon, there is no air to carry sound waves, so the world exists in a state of profound and perfect silence. A person standing on the lunar surface, inside their helmet, would hear only the sound of their own breathing and the soft hum of their suit's life support. The world outside would be a silent movie. A falling rock would make no sound, a rover driving past would be completely inaudible. This deep, pervasive quiet would be a fundamental part of the lunar experience, a state of sensory peace that is impossible to find anywhere on the noisy, restless surface of the Earth. The future of astronomy may involve a telescope that is not a single object, but a swarm of small, independent spacecraft flying in perfect formation. These satellites would spread out over millions of miles, and by combining the light they each collect using interferometry, they would function as a single, colossal lens. This formation-flying telescope could adjust its shape and size, reconfiguring itself to look at different objects with different levels of magnification. It would be a fluid and adaptable eye on the universe, a shimmering, computational web of observers that could achieve a level of detail and clarity that is physically impossible for any single, rigid structure. It would be an instrument as dynamic and graceful as the cosmos it observes. 85. The great swirling storms on Jupiter, like the Great Red Spot, are phenomena of incredible power, yet they unfold in a kind of majestic silence over centuries. These storms are vortices in the planet's atmosphere, larger than the entire Earth, with winds blowing at hundreds of miles per hour. Yet, because there is no solid surface for these winds to blow against, they can persist for hundreds or even thousands of years in a state of slow, graceful, and continuous motion. A probe looking down on these colossal weather patterns would see a silent, beautiful, and hypnotic ballet of color and form. A storm system so vast and so long-lived that it operates on a timescale closer to geology than to meteorology. 86. Our distant descendants may inhabit a universe that is growing cold and dark, and their homes will be built to last for trillions of years. In the far, far future, after the last stars have burned out, the universe will be a quiet, cold, and dark place. A truly advanced civilization might survive by building their homes around the last vestiges of heat and energy, the gentle radiation from slowly evaporating black holes. They would live in a state of extreme slowness, their thoughts and actions unfolding over immense geological timescales to conserve energy. It is a vision of a final, quiet, and peaceful state of existence, a civilization that has learned to live in perfect harmony with a silent and slumbering universe. 87. A future spacecraft might be coated in a paint that can change its properties on command. This smart surface could alter its color from a reflective white to a heat-absorbing black, allowing the ship to carefully manage its internal temperature. When the ship is in direct sunlight, the surface would turn white to reflect the intense heat. When it passes into shadow and begins to cool, the surface would turn black to absorb as much faint ambient radiation as possible. The entire ship would be able to gently and silently adjust its own skin, like a living creature, maintaining a perfect, stable, and comfortable environment for the crew inside, all without any moving parts, just a quiet and subtle shift of color. 88. The first human explorers on Mars will experience a sky that is not blue, but a soft, gentle butterscotch or salmon pink. This is due to the fine, reddish dust that is suspended in the planet's thin atmosphere, which scatters the sunlight in a different way than the gases of Earth's air. Sunsets on Mars would be a particularly beautiful and alien sight, with the area immediately around the setting sun appearing as a soft, ethereal blue, while the rest of the sky glows in faint, warm pastels. It would be a familiar daily rhythm, the setting of a star, but painted in a new and gentle palette of colors, a quiet and constant reminder that they are standing on the shore of a new and different world. 89. The exploration of planets with thick, opaque atmospheres, like Venus, might be done with robotic probes that move like blimps and see with radar. An aerobot probe could float indefinitely in the upper atmosphere, riding the winds and using a powerful ground-penetrating radar to slowly and patiently map the hidden surface below. It would be a form of exploration that is both gentle and blind, never directly seeing the world it is studying, but instead building up a detailed picture from the faint echoes of radio waves. Over many years, this quiet floating cartographer could reveal the continents, mountains, and volcanoes that lie hidden beneath the planet's eternal golden veil of cloud. 90. The most common form of life in the universe might not be complex or intelligent, but a simple, resilient microbe that drifts in the vacuum between the stars. The theory of panspermia suggests that life could be carried from one world to another on asteroids or comets. If this is true, then interstellar space itself might be filled with a thin, silent, and sleeping biosphere of the dormant microorganisms. These tiny, hardy travelers would be in a state of suspended animation, waiting patiently for a chance encounter with a warm, wet, and welcoming world. Life, in this view, is not a rare and isolated miracle, but a gentle, pervasive, and cosmic seed drifting silently on the slow, dark winds of the galaxy. 91. Future space habitats might be designed with a deep understanding of psychological architecture, using shapes and spaces that promote a feeling of calm and security. Instead of long, straight corridors, pathways might be gently curved and meandering. Living quarters would be designed to feel more like cozy, rounded caves or nests rather than sharp-angled boxes. The lighting would be soft and indirect, and the materials used would be warm and textured. The entire habitat would be engineered to be a sanctuary, a place that feels organic and safe, a gentle and protective shell to hold the minds and bodies in a state of peaceful equilibrium during their long and quiet isolation. 92. The slow, inevitable heat death of the universe is not a violent end, but a gentle and final fading into a state of perfect peace. In the unimaginably distant future, after all the stars have burned out and all the black holes have evaporated, the universe will approach a state of maximum entropy. All matter will have decayed into a thin, cold soup of elementary particles, and all energy will be evenly distributed. There will be no more change, no more motion, no more flow of time. It will be a state of ultimate, eternal, and absolute stillness and silence. It is the final, deep exhalation of the cosmos, a return to a state of perfect, quiet equilibrium, a final and gentle sleep. 93. The most efficient path between 2 points in the solar system is often not a straight line, but a long and graceful curve. These low-energy transfer orbits, sometimes called the interplanetary superhighway, are pathways that use the complex gravitational interactions of the planets and moons to gently guide a spacecraft on its way. A ship traveling along one of these routes would use very little fuel, but its journey would take a very long time. It would be a slow, meandering, and patient form of travel, like a sailboat choosing to follow the most favorable winds and currents rather than powering through in a straight line. It is a way of seeing the solar system not as an empty void to be crossed, but as a dynamic landscape of invisible hills and valleys to be gracefully navigated. 94. In the future, we may learn to see the universe not with light, but with the ghostly particles called neutrinos. Neutrinos are created in the hearts of stars and in violent cosmic explosions, and they travel through the universe almost completely unimpeded. They can pass through entire planets or stars without leaving a trace. Building a neutrino telescope is incredibly difficult, requiring vast detectors deep underground. But if we can perfect this technology, it would give us a completely new and unfiltered view of the cosmos. We could look directly into the core of our own sun, or watch a star collapse into a supernova from the inside out. It would be a quiet and ghostly form of astronomy, using the universe's most shy and elusive particles to see its most hidden and secret places. 95. A human-tended garden on Mars would be a place of quiet, simple, and profound beauty. Inside a warm, pressurized greenhouse, rows of green plants would grow under the soft glow of artificial lights. The contrast between the vibrant, living green inside and the silent, red, and barren landscape visible through the windows would be a constant and powerful source of comfort and wonder. The simple act of tending to these plants, watering the soil, pruning the leaves, would be a deep and meaningful connection to the cycles of life, a small piece of Earth's gentle rhythm carried to a new world. This garden would be more than just a source of food. It would be the green, living heart of the entire colony. 96. The energy to power an entire civilization might one day be beamed silently and invisibly through space. A vast array of solar panels, perhaps in a stable orbit around the Sun or the Earth, would collect enormous amounts of solar energy. This energy would then be converted into a tight, focused beam of microwaves and aimed at a receiving station on the ground. The receiving station, a large field of special antennas, would then convert the microwave energy back into electricity with high efficiency. This would provide a source of clean, constant, and limitless power, a gentle and invisible river of energy flowing down from the sky, freeing us from our reliance on the finite resources of our own small planet. The moons of Mars, Phobos and Deimos, are not spherical like our own moon, but are small, lumpy, and potato-shaped. They are likely captured asteroids, and in the distant future, they may become ideal outposts and transportation hubs. Their incredibly low gravity would make it easy to land on them and launch from them, turning them into natural space docks for ships traveling to and from Mars. They could be hollowed out to create habitats, shielded by the rock from cosmic radiation. These two small, tumbling mountains would become the quiet, bustling gatekeepers of the Red Planet, the first and last stops for every traveler on their long journey to and from the surface below. 98. The color of the stars we see in the night sky tells a quiet story of their age and temperature. The hot, young, and energetic stars burn with a brilliant blue or white light. Stars like our Sun, in the calm and stable middle age of their lives, glow with a gentle yellow, and the old, cool, and dying stars, having exhausted much of their fuel, radiate a soft, deep, and final red. A simple glance at the celestial canvas reveals a quiet and beautiful diversity of stellar life, a silent stellar population of infants, adults, and ancient ones. The night sky is not just a collection of glittering points, but a gentle and colorful portrait of cosmic birth, life, and slow, graceful decay. 99. The atmosphere of a distant exoplanet may one day be studied by looking for the faint, reflected light from its surface, a phenomenon known as planet shine. Just as our own moon is sometimes faintly illuminated by the light reflected off the Earth, a distant planet will be faintly lit by the light of its parent star reflecting off the clouds or oceans of its neighboring worlds. This incredibly faint, second-hand light carries a signature of the surfaces it has touched. By capturing and analyzing this ghostly glimmer with a powerful enough telescope, we could learn about the weather and geography of a planet that is otherwise completely hidden in the glare of its own sun. It is a way of seeing a world by the faint, gentle echo of its own light. 100. The final and most peaceful state of a mature spacefaring civilization may not be one of frantic expansion, but of quiet, contented stewardship. Having explored the worlds of its home star and learned the deep truths of the cosmos, a civilization might choose to live in a state of perfect, sustainable balance, turning its solar system into a single, beautiful, and interconnected garden. They would nurture life on every world that could support it and spend their long existence on art, science, and quiet contemplation. It is a future based not on the desire for more, but on a profound appreciation for what is. It is the vision of a civilization that has outgrown its wanderlust and has finally, peacefully, and completely come home. 101. The background hum of the universe itself will one day be a source of profound knowledge and quiet contemplation. This faint, gentle glow, known as the cosmic microwave background, is the oldest light in the cosmos, a faint, cool echo of the Big Bang's fiery birth. It fills all of space, washing over everything in a silent, invisible tide of ancient radiation. Future instruments, perhaps deployed in the deep, cold quiet beyond Neptune, will map this ancient light with incredible precision, listening to its faint temperature variations like a doctor listening to the heartbeat of a newborn. In these subtle fluctuations, we will read the story of the universe's first moments, the faint seeds from which all the great galaxies would one day grow. It is the universe's first and most gentle whisper, a lullaby that has been traveling through the darkness for nearly 14 billion years. A future civilization might power itself by gently feeding a spinning black hole. The theory, known as the Penrose process, suggests that energy can be extracted from the rotating vortex of spacetime that surrounds a black hole. An object or a packet of waste matter could be lowered into this swirling region, called the ergosphere, and then released. Part of the mass would fall into the black hole, but in doing so, it would propel the remaining part back out with more energy than it had to begin with. This extra energy is stolen directly from the black hole's own rotational momentum, slowing its spin by an infinitesimal amount. It would be the ultimate recycling plant, a quiet and efficient engine that turns unwanted mass into pure energy by feeding the gentle, spinning hunger of a slumbering giant. It is a way to draw power from the silent turning of spacetime itself. 103. The quiet, solitary work of robotic gardeners will be the first step in making the Martian soil come alive. These slow-moving, autonomous rovers would methodically crawl across the prepared ground inside a vast greenhouse dome, their metallic limbs performing a patient and gentle ballet of cultivation. One arm might till the reddish, dusty soil, while another carefully places a seed or a seedling into the ground. A third arm would follow, dispensing a precise and precious amount of water and nutrients. These robots would work tirelessly under the soft, artificial sunlight, day and night, slowly transforming a sterile patch of alien dust into the first fertile fields of a new world. They would be the quiet, humble farmers of Mars, their patient labor the foundation of a future where green things can grow under a pink and distant sky. 104. The deepest and most isolated parts of Earth's oceans will be the quiet training grounds for our first missions to the icy moons of the outer solar system. In the profound, crushing darkness beneath miles of water, we will test the autonomous submarines destined to explore the hidden oceans of Europa or Enceladus. These missions will simulate the immense communication delays and the complete lack of human intervention that will define those future voyages. A probe released into the Mariana Trench will be truly on its own, navigating the abyssal plains and hydrothermal vents in a silence as complete as deep space. It is here, in the quiet, hidden worlds of our own planet, that we will teach our machines the patience, resilience, and gentle intelligence they will need to search for life in the lonely, dark waters of a distant world. 105. The air inside a long-duration starship will be kept fresh and clean by a silent, living, breathing wall of green. Instead of mechanical scrubbers and filters, a significant portion of the ship's interior walls could be devoted to a vertical ecosystem of mosses, algae, and hardy plants. This living wall would be a quiet and beautiful part of the life support system. It would naturally absorb the carbon dioxide exhaled by the crew, and through the gentle, silent process of photosynthesis, it would release fresh, clean oxygen back into the air. The water recycling system would keep its roots moist, and its slow, steady growth would be a comforting and constant sign of life on a journey through the sterile void. It would be a system of profound elegance, a quiet, green lung for a vessel sailing the blackest of seas. 106. The psychology of future astronauts will be shaped by the profound and humbling experience of seeing the Earth shrink to a pale blue dot. As their ship pulls away from our homeworld, they will watch as continents resolve into clouds, and then the entire planet becomes a small, bright marble, and then, finally, just another point of light among the countless stars. This overview effect is often described as a moment of quiet, spiritual awakening, a sudden and deep understanding of the preciousness and interconnectedness of all life on our small, fragile world. This perspective, a feeling of being a citizen of not a country, but of a planet, will be a defining feature of the first interstellar travelers, a quiet and profound sense of home that they carry with them no matter how far they roam. 107. The future calendar for a Martian colony will have its own unique and gentle rhythm. Because a Martian year is nearly twice as long as an Earth year, and a Martian day, or sol, is about 40 minutes longer, the colonists will live by a new clock and a new calendar. Seasons will be long and slow, with gentle, extended springs and deep, quiet winters that last for many months. The extra 40 minutes in each sol might be a designated period of quiet reflection or community time, a peaceful pause built into the structure of every day. This new way of marking time will subtly reshape the colonists' relationship with their world, creating a culture with a slower, more patient, and more deliberate pace, a rhythm of life perfectly attuned to the silent, stately turning of their new red world. 108. The beautiful, silent plumes of ice that erupt from Saturn's moon Enceladus will be a source of profound scientific discovery. This small, bright moon is known to have a global ocean of liquid water beneath its icy shell, and great geysers near its south pole continuously spray jets of this water, ice, and organic molecules far out into space. A future probe could simply fly through these gentle, glittering plumes, gently collecting samples without ever needing to land. It would be like a cosmic honeybee gathering the nectar of a distant world. By analyzing this material, we could learn the secrets of the hidden ocean below, searching for the chemical signatures of life in a way that is quiet, non-invasive, and deeply respectful of the pristine world it is studying. 109. The silent dance of orbital cleanup robots will be a crucial and constant task in maintaining our pathway to the stars. Swarms of these autonomous janitors will gracefully move through low Earth orbit, their mission to gently collect the millions of pieces of space debris left over from decades of launches. Some might use fine gossamer nets to capture clouds of small fragments, while others might use robotic arms to carefully grab a large defunct satellite. Once captured, this debris would be nudged into a decaying orbit where it can safely burn up in the atmosphere. It would be a quiet, constant, and understated ballet of housekeeping, a slow and patient sweeping of our cosmic doorstep to ensure that the road to the future remains open and clear. 110. A city built within a hollowed-out asteroid would experience a strange and gentle kind of sunlight. The interior of this worldlet would be illuminated by a central artificial light source, a miniature sun that runs along the spin axis. But this light could be supplemented by a vast network of mirrors on the asteroid's surface. These mirrors would capture the real sunlight from outside and channel it through a series of fiber optic cables to the interior, where it would emerge from glowing panels in the sky. This would be a soft, natural, and full-spectrum light, changing in intensity and color to mimic a normal day-night cycle. The inhabitants would live under a gentle, borrowed sunlight, a quiet and constant connection to the star their home is orbiting. 111. The strange, perpetual twilight on a tidally locked exoplanet will create a world of profound and beautiful contrasts. On such a planet, which always keeps the same face towards its star, there would be a ring of eternal dawn or dusk between the scorched, sun-baked hemisphere and the frozen night side. In this Terminator zone, the star would hang forever on the horizon, casting long, soft shadows and bathing the landscape in a gentle, permanent twilight. This would be the most habitable region of the planet, a world of soft light and moderate temperatures. Any life that evolved here would be perfectly adapted to a world without day or night, a quiet and peaceful existence in a land of endless, silent sunset. 112. The quiet work of an archivist on a generation ship will be one of the most sacred duties of the long voyage. This person would be the curator of memory, the keeper of the complete digital records of Earth's history, culture, and biology. They would maintain the vast libraries of books, music, and art, and tend to the silent, sleeping digital consciousnesses of humanity's greatest minds. Their role would be to ensure that the memory of a world their descendants will never see is not lost to the quiet decay of data over centuries. It would be a solitary and deeply contemplative existence, a life spent in communion with the ghost of a distant past, all to provide a quiet and unbroken thread of meaning for a far distant future. The silent, beautiful auroras that dance in the skies of the gas giants are a sign of their immense and powerful magnetic fields. On Jupiter, these curtains of light are thousands of times more powerful than Earth's, and they are sparked not just by the solar wind, but by the material vented from the volcanoes of its moon Io. A future probe orbiting Jupiter would be treated to a constant, silent, and spectacular light show, with shimmering, electrified gases forming vast, glowing rings around the planet's poles. It would be a vision of cosmic weather on a truly colossal scale, a quiet and beautiful testament to the invisible magnetic forces that shape the environments of these distant giant worlds. 114. We might one day move our entire solar system through the galaxy using a machine of almost unimaginable scale. The concept, known as a Shakatov thruster, involves building a colossal curved mirror, or statite, that would be placed in a stable orbit around the Sun. This mirror would reflect a significant portion of the Sun's radiation in a single direction. The gentle but constant pressure of this reflected sunlight would create a tiny net thrust, which would, over millions of years, slowly accelerate the entire solar system with the Sun and all its planets in tow. It would be a project of geological patience, a quiet and gentle way for a civilization to steer its home star on a long, slow journey to a safer or more interesting part of the galaxy. 115. A habitat on the Moon or Mars could be shielded from radiation by a thick, transparent layer of water ice. Imagine a great domed structure with a double-paned ceiling. The space between these two panes, many feet thick, would be filled with water. This layer of water is an excellent and surprisingly clear shield against heavy cosmic rays and solar radiation, providing protection while still allowing the natural, faint sunlight to filter through. The inhabitants would live under a soft aquatic sky, with the light from the outside gently diffused and softened by the water above. It would create a serene and peaceful environment, a quiet and constant feeling of being safe and sheltered beneath the surface of a clear, calm pond. 116. The feeling of walking on Mars will be a strange and gentle experience of light-footedness. The gravity on the Martian surface is only about 38% of Earth's, which means that every step will feel like a soft, floating bounce. A person could jump 3 times higher than they could on Earth, and a gentle jog would feel like a slow-motion, effortless glide across the landscape. This constant light buoyancy would become a normal part of life, subtly changing the way people move, play, and interact with their world. It would be a quiet and constant physical reminder of being on another planet, a gentle freedom from the full weight of the world they once knew. 117. The first Martian soils will be created in a slow and quiet process, mimicking the work of nature. The sterile, reddish regolith, which is little more than crushed volcanic rock, will be slowly enriched in large, pressurized agricultural bays. Organic waste from the colony will be composted and mixed into the dust, along with carefully selected colonies of nitrogen-fixing bacteria and hardy earthworms. Over many years, this quiet biological and chemical process will transform the dead dust into a dark, rich, and fertile loam, capable of supporting a wide variety of crops. It will be an act of planetary alchemy, a slow and patient creation of the living ground that will one day feed a new branch of humanity. 118. The star field seen from the windows of a ship traveling near the speed of light would be a strange and beautiful spectacle. Due to the effects of special relativity, the light from the stars ahead of the ship would be blue-shifted, becoming brighter and more intense. The stars to the sides and behind would be red-shifted, appearing dimmer and redder. As the ship approached light speed, all the visible stars would appear to crowd into a single, brilliant, tunnel-like window directly in front, while the rest of the sky would grow dark. It would be a quiet and profound distortion of reality, a silent and beautiful reminder that the very appearance of the universe is a conversation between the cosmos and the motion of the observer. The quiet, cool, and silent interiors of ancient lava tubes on Mars will provide the first natural homes for humanity. These great underground tunnels, formed by flowing lava billions of years ago, offer a pre-made and perfectly shielded environment. Explorers will enter these vast, dark caverns and find a place of profound stillness and stable temperatures, a natural sanctuary from the harsh conditions on the surface. Inside these silent, geological veins, inflatable habitats can be deployed, creating well-lit and comfortable underground towns. Life would unfold in the quiet, protected heart of the planet itself, a peaceful existence in a place that has been waiting, empty and silent, for a new kind of life to arrive. 120. The exploration of delicate and unknown alien environments might be done by robots that are soft, gentle, and yielding. Instead of hard, metallic machines, these soft robots would be made of flexible, silicone-like materials, and they would move not with gears and motors, but by having air or fluid pumped through their bodies. They could squeeze through small cracks, absorb impacts without breaking, and interact with their environment with a gentle, compliant touch. A soft robot, perhaps shaped like an octopus or a caterpillar, could be the perfect explorer for the fragile ecosystems that might exist under the ice of Europa, able to gently probe and observe without crushing or contaminating the very life it is looking for. 121. The quiet and painstaking work of restoring a damaged Earth will be greatly aided by the lessons learned in space. The perfectly closed-loop life support systems designed for a Martian colony or a generation ship will be the ultimate models of sustainability. These systems, where every drop of water, every breath of air, and every scrap of organic waste is perfectly repurposed, will teach us how to live in a state of delicate and efficient balance with our environment. The technologies developed for these small artificial worlds will be brought back home, providing a quiet and powerful blueprint for how to heal our own planet, turning our entire world into the one great self-sustaining starship it was always meant to be. 122. The quiet, circular logic of a perfect water recycling system is a form of deep technological peace. On a long-duration mission, every single drop of water will be a precious resource, carefully collected and repurposed in an endless loop. The moisture from an astronaut's breath, their perspiration, and all their wastewater would be collected, filtered, and purified at a molecular level until it is cleaner than any spring water on Earth. This water would then be used for drinking, rehydrating food, and watering plants. This perfect closed circle, with nothing ever lost or wasted, is a quiet and constant demonstration of a profound harmony between technology and the fundamental needs of life, a gentle and unending cycle of renewal. 123. A solar eclipse, as seen from the surface of the moon, would be a slow, silent, and deeply beautiful event. Instead of the sky growing dark, an observer on the moon would see a small, dark circle, the Earth, slowly pass in front of the sun. But the Earth would not be completely black. It would be surrounded by a brilliant, delicate, and glowing red ring. This ring would be the light of every single sunrise and every single sunset on Earth, all happening at the same moment, their light refracted through the thin shell of our planet's atmosphere. It would be a quiet and breathtaking vision, seeing the entirety of our world's dawn and dusk captured in a single, silent, and fiery halo. 124. The patient sifting of asteroid dust for traces of organic molecules will be a quiet form of cosmic archaeology. Robotic labs on mining outposts will analyze thousands of samples of this pristine ancient material, which has remained largely unchanged since the formation of the solar system. They will be searching for the complex carbon-based molecules, the amino acids, and other compounds that are the fundamental building blocks of life as we know it. Finding these molecules would be a quiet and profound confirmation that the ingredients for life are not unique to Earth, but are common and widespread throughout the cosmos. It would be like finding the faint, gentle fingerprints of life's potential, scattered silently across the entire solar system. 125. The strange and beautiful crystals that might grow in a zero-gravity laboratory would be a form of quiet, perfect art. On Earth, the force of gravity affects the way crystals form, introducing small imperfections and limiting their size. But in the weightless environment of a space station, a crystal can grow slowly and perfectly in a liquid solution, with its atoms arranging themselves into a flawless, symmetrical lattice. Scientists could grow crystals of proteins for medical research, or new materials for advanced electronics, that are larger and more perfect than any that could be made on the ground. It would be a quiet and patient form of creation, allowing the universe's own deep geometric tendencies to express themselves in their most elegant and undisturbed form. 126. The most profound stillness in the solar system can be found inside a permanently shadowed crater on the Moon. Near the lunar poles, there are deep craters whose floors have not seen a single ray of direct sunlight for over 1 billion years. The temperatures in these places of eternal night are among the coldest ever measured, colder even than the surface of Pluto. These craters are perfect cold traps, and they are thought to contain vast, ancient deposits of pristine water ice. A future habitat built here would exist in a state of profound, deep, and unchanging quiet. It would be a place of perpetual, gentle twilight, a sanctuary of stillness where the only light comes from the soft, distant glow of the surrounding stars. 127. The gentle, colorful glow of a nebula is the sign of a quiet and beautiful cosmic nursery. These vast clouds of interstellar gas and dust are the places where new stars and their planetary systems are slowly being born. Over millions of years, the gentle force of gravity slowly pulls the material in these clouds together into denser and denser clumps. As these clumps grow, they begin to heat up, eventually becoming hot enough in their cores to ignite nuclear fusion and blaze forth as new stars. A telescope pointed at a nebula is looking at a scene of serene and silent creation, a vast, gentle, and ongoing process that is seeding the galaxy with new light, new warmth, and new possibilities for life. 128. The most efficient way to travel in space may be to harness the violent energy of solar flares. A spacecraft with a vast, powerful magnetic sail, or magsail, could be positioned to ride the wave of a solar storm. When the sun unleashes a coronal mass ejection, it sends a huge cloud of charged particles rushing out into the solar system. The magsail's powerful magnetic field would act like a parachute in this particle wind, catching the immense blast and being propelled to incredible speeds. It would be a form of cosmic surfing, a quiet and skillful way to turn the sun's most violent and unpredictable moods into a gentle and powerful push towards the farthest reaches of the solar system. 129. The sport of the future might be a silent, three-dimensional game played in the zero-gravity environment of a large, open chamber on a space station. Two teams would float in the open space, and the objective would be to move a ball or a beam of light into a goal. Without the constraints of up or down, the game would be a complex and graceful ballet of strategy and movement, with players pushing off walls, ceilings, and each other in a slow, controlled, and silent dance. It would be a sport that is less about brute force and more about gentle precision and profound spatial awareness, a beautiful and quiet expression of the human body's joyful adaptation to a new and weightless world. 130. The feeling of holding a rock from another world in your hand would be a moment of quiet and profound connection. Imagine a geologist on Mars picking up a small, reddish stone that has laid in the dust for 1 billion years. Or an astronaut on the moon, collecting a piece of the bright, ancient highlands. This simple, tangible object would be a direct physical link to a world beyond our own, a silent ambassador from a different realm. It would be a moment that transcends science and becomes something deeper, a quiet, tactile reminder of the vast, diverse, and accessible universe that lies just beyond our own blue sky. A silent testament to a journey of millions of miles. 131. The quiet, computerized health checks a starship performs on itself will be like a form of deep, mechanical meditation. During the long, silent years of an interstellar voyage, the ship's master AI would constantly be running gentle diagnostics on every one of its millions of systems. It would feel the subtle vibrations in the hull, taste the chemical composition of the air, and listen to the faint electrical hum of its own mind. It would be a state of constant, quiet self-awareness, always checking for the smallest sign of disharmony or decay. This slow, patient, and unending process of self-maintenance is what would allow the ship to endure the centuries-long journey, arriving at its destination as healthy and as peaceful as the day it left. 132. The slow, graceful dance of two spacecraft docking in orbit is a ballet of immense precision and gentle trust. Two massive objects, moving at thousands of miles per hour, align themselves with a tolerance of less than an inch, their movements guided by quiet, computerized thruster firings. The final approach is a slow, methodical, and almost tender process, as the two ships come together with a barely perceptible touch. There is no sound, only the quiet confirmation of a connection made, a secure latching that joins the two vessels into a single, larger whole. It is a moment of profound, silent, and technological grace, a demonstration of perfect harmony between two complex machines in the vast, empty ballroom of space. 133. The peace of watching a moonrise from the surface of Mars would be a familiar yet deeply alien experience. The two small moons, Phobos and Deimos, would not rise with the slow majesty of our own moon. They would appear as small, bright, and fast-moving points of light, looking more like bright planets or satellites than true moons. Phobos, the closer of the two, would whip across the sky in just a few hours, and would appear to rise in the west and set in the east, opposite to everything else in the Martian sky. Watching these two small, captured worlds perform their quick and silent dance would be a unique and gentle Martian pastime, a quiet and beautiful celestial clock for a new world. 134. The quiet hum of the solar panels on a lunar outpost would be the steady, gentle heartbeat of the entire settlement. These vast, dark wings would stretch across the gray landscape, silently drinking in the raw, unfiltered sunlight. Throughout the long 2-week lunar day, they would slowly and gracefully turn, tracking the path of the sun across the black sky with perfect, silent precision. The energy they gathered would power everything, from the air recyclers to the scientific labs to the soft lights of the living quarters. This constant, quiet, and reliable flow of energy from a distant star would be the gentle, life-giving pulse that makes a human presence possible in such a silent and barren place. 135. The vast, empty spaces between the galaxies will be the next great frontier for a truly advanced civilization. Journeys across this intergalactic void would be voyages of profound and unimaginable loneliness and duration, taking millions of years. A ship making such a journey would be a true, self-contained universe, a tiny spark of life and consciousness crossing an abyss of almost perfect nothingness. The view from the windows would be one of deep, unchanging stillness, with the faint, fuzzy smudges of distant galaxies remaining almost motionless for entire human lifetimes. It would be the ultimate journey into the quiet, the deep, and the unknown, a voyage for a species that has learned to measure its life in the slow, patient rhythm of cosmic time. 136. The cuisine of a spacefaring culture will be a creative and gentle art form, born of necessity. With a limited palette of ingredients, all grown within the closed environment of the habitat, cooks would become masters of texture, flavor, and presentation. Algae and microbial proteins might be formed into delicate noodles, and the leaves of genetically modified sweet potatoes might be used as a versatile green. Every meal would be a quiet and mindful celebration of the preciousness of food, a testament to the ingenuity that allows a small, green, and vibrant oasis of life to flourish in the most sterile of environments. The simple act of sharing a carefully prepared meal would be a deep and comforting ritual of community on the long journey between worlds. 137. A world that is tidally locked to a red dwarf star would be a place of eternal, gentle warmth. These small, cool stars have very long lifespans, and a planet in a close, tidally locked orbit could maintain stable, liquid water on its surface for trillions of years. Life on such a world would evolve in the perpetual, soft, reddish light of the Terminator Zone, the strip of gentle twilight between the hot and cold sides. It would be a quiet, ancient, and profoundly stable ecosystem, a world that has known nothing but an endless, peaceful afternoon for longer than our own sun has existed. It is in these quiet, gentle gardens that life may have its best chance to endure into the deep, far future of the universe. 138. The quiet, painstaking process of mapping the magnetic field of a new world is like learning to see its invisible soul. A probe in a low orbit would circle the planet for months, its sensitive magnetometers patiently measuring the strength and direction of the faint magnetic forces around it. Over time, these countless individual measurements would be woven together by a computer to create a complete three-dimensional map of the planet's magnetosphere. This map would reveal the secrets of the planet's deep interior, the churning of its liquid metal core, and the shape of the invisible shield that protects it from the solar wind. It would be a quiet and gentle way to understand the deep, hidden, and dynamic heart of a silent and distant world. 139. The silent beauty of the universe may one day be captured not by cameras, but by devices that translate cosmic data directly into a sensory experience. Imagine a room where the light from a distant nebula is converted into a gentle, shifting pattern of colors that wash over the walls. The radio signals from a spinning pulsar could be translated into a deep, rhythmic, and physical vibration felt through the floor. The composition of a distant planet's atmosphere could be represented as a complex and evolving scent. This would be a new and more profound way to experience the cosmos, a quiet and immersive art form that allows us to feel the silent, invisible data of the universe as a direct and personal sensation of peace and wonder. The most advanced spaceships may have no discernible engine at all, moving through the void in perfect silence. Such a ship might be propelled by subtly warping the fabric of spacetime itself, a concept known as an Alcubierre drive. It would work by creating a region of expanding spacetime behind the ship and a region of contracting spacetime in front of it. The ship itself would rest in a calm, flat bubble of normal spacetime in the middle, and this bubble would be pushed along by the distortions around it, like a surfer on a wave. The ship would not be moving through space, but would be carried along with its own personal moving piece of space. It would be the ultimate in gentle, quiet travel, a way to cross the stars without ever firing a thruster. 141. A future human society living on an extrasolar planet will eventually develop its own unique and gentle accent. Over many generations of relative isolation, separated from Earth by light years of silent space, their language would slowly and naturally drift. New words would be invented for the strange new plants and animals of their world, and the cadence of their speech would subtly change, influenced by the rhythms of their new environment. Listening to a person from such a world would be a quiet and beautiful experience, hearing a familiar language that has been gently reshaped by a different sun, a different sky, and a different history. It would be the quiet, audible proof of humanity's slow and peaceful branching into a truly galactic species. 142. The rings of Uranus are a strange and beautiful mystery, as dark and faint as ghosts. Unlike the bright, icy rings of Saturn, the rings of Uranus are composed of incredibly dark, coal-black material, making them almost impossible to see. A future probe sent to explore them would be a traveler in a realm of deep shadow and subtle form. It would find a system of thin, dark, and delicate ribbons, some no wider than a highway, orbiting the planet in a state of profound and silent grace. It would be an exploration of the solar system's most understated and quiet beauty, a gentle and careful study of a celestial structure that whispers its presence rather than shouting it across the void. 143. The most important tool for the first colonists on another world will be a quiet and profound sense of patience. Nothing on a new world will be easy or fast. Building a habitat, creating a breathable atmosphere, and growing the first crops will be slow, methodical processes that take generations. The first settlers will not be daredevils and adventurers, but careful, patient gardeners and builders. Their greatest triumphs will be measured not in days or weeks, but in decades. They will be a society that understands the deep, quiet, and immense value of slow and steady work, a culture that knows how to plant a tree under whose shade they will never personally sit. 144. The great oceans inside the icy moons of our solar system might be warmed not by sunlight, but by the gentle, constant squeezing of their parent planet's gravity. A moon like Europa, as it orbits Jupiter, is constantly being flexed and stretched by the giant planet's immense gravitational pull. This constant tidal friction generates a small but steady amount of heat in the moon's core, which is enough to keep its vast, hidden ocean in a liquid state. Life in such an ocean would be completely independent of the sun, drawing its energy not from light, but from the chemical nutrients released by hydrothermal vents on the seafloor. It would be a world powered by a quiet, gravitational heartbeat, a gentle and rhythmic flexing that provides a constant and enduring warmth. 145. A future terraformed Venus with a cooler surface and liquid water oceans would be a world of slow and gentle weather. Because the planet rotates so incredibly slowly, with a day that is longer than its year, there would be no powerful Coriolis effect to whip up storms into fast-moving cyclones. Weather patterns would be vast, slow-moving, and continental in scale. A rainstorm might take weeks to drift across an ocean, and the winds would be gentle, persistent breezes rather than powerful gales. It would be a world of profound meteorological calm, a place where the sky moves with a quiet, stately, and majestic patience, a perfect mirror of the planet's own slow and graceful turning. 146. The quiet beauty of a perfectly clear night sky, seen from a remote outpost on the Moon or Mars, will be a treasure beyond measure. With no atmosphere to scatter the light or blur the view, the stars will not twinkle, but will shine with a pure, steady, and unwavering intensity. The Milky Way will stretch from horizon to horizon, not as a faint, milky band, but as a brilliant, textured river of light, so bright it casts soft shadows on the ground. The familiar constellations will be embedded in a fine, shimmering dust of countless fainter stars, invisible from Earth. It would be a view of the universe in its most raw, majestic, and silent form, a nightly spectacle of such profound and peaceful beauty that it would become the quiet, spiritual heart of any off-world culture. 147. The future of planetary science may lie in creating miniature, living worlds inside sealed laboratory biospheres. Imagine a large, closed chamber where scientists can perfectly replicate the atmospheric pressure, gas composition, and temperature of early Mars. They could then introduce hardy, genetically engineered lichens and microbes and watch, over many years, how they slowly and gently change their environment. These sealed worlds would be a quiet and patient way to test our terraforming theories, a chance to make our mistakes on a small and harmless scale. They would be tiny, living pocket universes, gentle rehearsals for the great and patient work of one day breathing life into a sleeping, red world. 148. The gentle, artificial tides inside the oceans of a great rotating space habitat will be a constant, calming presence. As the O'Neill cylinder spins to create gravity, the water in its long, axial rivers and lakes will be pulled by Coriolis forces, creating a slow, rhythmic sloshing, a gentle and predictable wave that moves up and down the banks over the course of the day. This soft, manufactured tide would be a quiet and constant reminder of the physics that makes their world possible. Children born in the habitat would grow up with this gentle, rhythmic pulse as a natural and comforting part of their world, a slow and silent heartbeat for their vast cylindrical home. 149. The ultimate goal of our cosmic journey may be to simply and quietly listen. As our technology for detecting the faint signals of the universe grows more sensitive, we may find that the cosmos is filled with a rich and complex symphony of natural, non-biological signals. We might learn to interpret the gravitational wave signatures of merging black holes as a form of cosmic music, or the complex radio emissions of pulsars as a kind of celestial poetry. Our future in space may be less about speaking and more about learning to appreciate the immense, profound, and beautiful symphony that the universe has been playing in perfect silence all along. It would be the act of a species that has finally learned to be a quiet and respectful audience to a performance of cosmic scale. 150. And the final, most relaxing thought is that you are already a quiet and ancient traveler of the cosmos. Every single atom in your body, except for the very oldest hydrogen, was forged in the heart of a star that lived and died billions of years ago. You are made of stardust. You are a small, temporary collection of ancient light and matter that has been on a journey across the galaxy for eons. You are not separate from the universe. You are a living, breathing, and dreaming part of it. The same gentle laws that guide the planets and shape the stars are the laws that hold you together. And so, as you drift off to sleep, you are simply continuing a long and ancient journey, a quiet and peaceful drift on a silent cosmic tide. And so, our gentle drift through the starlit worlds of tomorrow comes to a soft and quiet end. The shimmering sails have been furled, the silent engines have been hushed, and the distant imagined landscapes begin to fade, like constellations at the soft edge of dawn. The great, slow current of possibility that carried us through the quiet void is slowing now, becoming a wide and peaceful river as it nears the great, silent ocean of your sleep. There is nothing left to build or to explore, no new worlds to imagine. All that remains is this peaceful moment, this quiet harbor, a place of perfect stillness and rest. Let the journey dissolve behind you, leaving only a faint, lingering sense of wonder, like the soft afterglow of a distant star. The great cosmic story of what could be has been told for tonight, and now it is time for the quiet, personal story of your own deep rest to begin. We have wandered through a future that is not built on speed and noise, but on a profound and gentle patience. We have felt the quiet push of starlight on a vast, transparent sail and listened to the faint, blue whisper of an engine that travels with the persistence of a single falling drop of water. We have imagined green and living worlds, sealed in great spinning vessels, their inner skies filled with a soft and artificial sun. We have dreamed of silent robotic gardeners tending to the first fields of a new world, and of graceful ships that dance with gravity, riding its invisible currents from one planet to the next. This was not a future of conquest, but of quiet harmony, a time when humanity has learned to move with the same slow, majestic, and silent grace as the cosmos itself. It is a future that waits not with a roar, but with a deep and peaceful hum, a lullaby of what we might one day become. And you are a part of this gentle and unfolding story. The very atoms that make up your body were forged in the heart of a star, and they have been on a long and silent journey for billions of years to arrive here, in this moment, to rest with you. The iron in your blood and the calcium in your bones are the ancient dust of exploded suns, and they still hold a quiet, sleeping memory of the great starry ocean. The dreams you dream tonight are a small and beautiful part of the great collective dream that will one day carry us to these quiet and distant shores. The future is not just a place we go to, but a gentle thought we hold, a seed of possibility that we nurture in the quiet, fertile darkness of our rest. You are a child of the cosmos, and in your quietest moments, you are dreaming your way back home. So now, let your own journey begin. There is nowhere else you need to be, nothing you need to hold on to. Give yourself permission to let go completely. Let your thoughts drift away, like lonely, silent probes into the deep, peaceful darkness. Let your body grow heavy and still, anchored gently to the quiet, sleeping world beneath you. Feel the slow, easy rhythm of your breath, a soft and steady tide carrying you out into a calm and dreamless sea. May your rest be as deep and as silent as the space between the stars, and may your dreams be as peaceful as a slow orbit around a quiet, sleeping moon. There is only rest here. There is only peace. Good night.